half of this chapter is where we get to our proofs. Now, proofs in this chapter, one of the things you're going to notice for many of them is many of them are actually significantly shorter. They also are all extremely similar to one another. But there's a couple things we got to talk about before we actually get to doing the proofs. So, while you have the ability to use all of your postulate sheets, and I recommend that you have all of your postulate sheets, one of the things that's on top of this new postulate sheet is some reminders of things that we know from previous, and also technically an adjustment that we make to them. From previous chapters, we've talked about vertical angle theorem, alternate exterior angle theorem, corresponding angles postulate, alternate interior angle theorem, definition of angle bisector. These are all things that when we worked with them in previous chapters, they allowed us to say that things are equal. But as we get into today's proofs, we don't want things actually to be written out as equal, we want them to be written out as congruent. So all of these things can also lead to congruences. A couple that deal with congruent segments that we've worked with before are definition of midpoint and definition of segment bisector. These can also lead to congruencies. These things were all about angles, these things were about segments. And then we have two more things that we've technically talked a little bit about before, but we haven't necessarily given them a formal use. There's the right angle congruence theorem. Right angle congruence theorem just says that if you are given something and you are told that it is a right angle, all right angles are congruent. So if I'm told angle A and angle B are right angles, I can say angle A is congruent to angle B. And then there's the reflexive property. Now we've seen the reflexive property before. Technically, we saw the reflexive property of equality. It's one that in proofs it never came up because it didn't have a use before. A reflexive property is something that says it's congruent to itself. This will start to come up in this chapter anytime you have shared sides or angles. So, in our notes packet, we are opening up to page 11. Again, if you want to have your other postulate sheets out, it wouldn't be the worst thing in the world. Wink, wink. Nudge, nudge. Grab out the yellow and the orange.
Yeah, throw them away.
Why? I told you you get to use them. I told you you keep them. You get to use them on future chapters.
Don't worry, I got mine.
So, if you do not have them, you're going to probably want to get new ones. I will get you new ones here shortly. Okay. So, today we are proving triangles are congruent using what's known as SAS. SAS is the side angle side congruence postulate, which in proofs we just shorten down to SAS. It says that if you have two triangles in which you know there are two pairs of congruent sides, as well as the included angle being congruent, the included angle is the between angle of the two triangles. That is enough to say the triangles are congruent. Without this theorem, the only way that I could say triangles were congruent is if I showed that every single pair of corresponding parts is congruent. In other words, I would have to show all three sides and all three angles as congruent. I'd have to show 6 things in a proof to say they were congruent. not so fun. So, things like side angle side are shortcuts. They're shortcuts that always work, and so we're allowed to do them. So, if I have a picture like this, side angle side would look like me saying AB is congruent to DE. I do recommend you mark these pictures as well as write the words that I'm writing. That's one pair of sides. We would also have that BC is congruent to EF. And we would also have that angle B is congruent to angle E. So both triangles are set up right now where there are two pairs of congruent sides and the angle between them. In order to say that triangles are congruent by SAS, that is all of the information I need. I need both pairs of sides and the angle between to be congruent in both triangles. If you have something set up where, say, one triangle has something that looks like this and the other triangle has something that looks like this, that does not work because two sides, angle between must be true on both triangles. This is two sides, but it's not the angle between. So if I have both triangles with this setup, then I can say the triangles are congruent. Triangle ABC is congruent to triangle. Now, just like when we were talking about corresponding parts, we have to be very particular about what order things go in. The first triangle I can name in whatever order I want. The second triangle's order must match. Angle A is right here on my picture. It is not the congruent angle. So, when I go to my other one, I can't use the congruent angle to start it off. I have to use the angle that's at the end of the single marked side. Which angle do I start with in this triangle? D. Now I chose to go from A to B. B was the congruent angle. So I'm going to E next. And then F must be last then. So, here's what these proofs are going to look like. Just like all other proofs, when I see given and prove, I'm making my two columns. First column is my statements, second column is my reasons, and every single proof, regardless of the proof, starts with given. I have two givens on this one. Just like before. We can go through our 5 things. Now, not all 5 things are going to be relevant in these problems, but they are what we have available to us. It's the first thing we look for in proofs. Words. Do I have any words? Yeah, I have multiple words. So I'm going to deal with them one by one. First word I notice is midpoint. Now midpoint shows up on 2 sheets. It shows up on orange and it shows up on green now. Orange told us it allowed us to say things are equal. Green says it does more than equal, it also does congruence. Midpoint allows us to say that we have some congruent segments. Use your picture to kind of see what it is. Segment AD has B as its midpoint? Do you see two segments? When I did the purple there, do you see two segments popping up in that purple part? That's the only thing I drew out. What are the names of the two segments? AB and BD. AB is congruent to BD. According to our green sheet, when we see midpoint, that's definition of midpoint. Now, in these proofs, as soon as you mark something congruent in the proof, mark it as congruent in the picture. Segments get tick marks. We move on to the next step. I used the word midpoint. What word have I not used? Right angles. Right angles show up on both your orange sheet and your green sheet. Your green sheet's going to probably be more helpful at this point. Green sheet gives us a situation where we're told two angles are right angles. Were we told two different angles are right angles? Yes. According to this, if two angles are right angles, then they are congruent. Angle ABC is congruent to angle DBC. According to our green sheet, what theorem or postulate did we use? Yes, that was the right angle congruence theorem. I go to my picture and mark angle ABC and angle DBC is congruent. Now they're already marked as right angles, which means I know it's this one and this one. I'm just going to go over the top of it, mark it as congruent. In these proofs, I need 3 pairs of congruent symbols. How many congruent symbols are currently in my proof? 2. I need 1 more. So, I go through all of my things. We took care of words. There are congruent symbols. Yay, we're happy. What's the third thing we look for in proof? Algebra. We don't do algebra in these proofs. Skip. The fourth thing we look for, substitution and transitive property. For the most part, it doesn't show up in these proofs. The fifth thing we look at is the picture. From these pictures, we still have things like vertical angles, linear pairs, but for the most part, from a picture, those will come up. This is another one that's from a picture. Now, since I'm wanting congruencies, there's going to be limited things that come out of pictures. Vertical angles is one of them. Is there vertical angles in this picture? No, vertical angles are the ones that look like an X. I don't see no X's in this picture. So there's no vertical angles. Other things that give me congruencies technically are all of these theorems, but these require parallel lines. I don't see a parallel line symbol. Moving on. Our newest one that we get from a picture is if you see the triangles sharing a side or sharing an angle. Do the triangles overlap, sharing either having the same side or the same angle? See a couple people shaking their heads. What do they share? CB or BC. They share this segment. Anytime they share that, you can say that that thing is congruent to itself. And its reason is the reflexive property. soon as I mark things as congruent in the proof, I mark them in the picture. How many congruencies do I currently have in my proof? 3. How many did I say we need? 3. Okay, I have 3 congruents, so I look at my picture and I ask myself, is it in the side angle side setup? Are there 2 sides, and is it the angle between in both pictures? 2 sides, is that the angle between? Okay, that's the first triangle. Now I look at this triangle. That's 2 sides, is that the angle between? Sweet. Then by side angle side, I can say the triangles are congruent. Look at what it says you're trying to prove. Triangle ABC is congruent to triangle DBC. It tells me, for now, what to put in my proof. If you're not sure, you match up the parts. This is a proof that's on the longer side for this chapter. All 5 steps of it. That is a longer proof in this chapter. Let's do a couple more. Statements, reasons. Every single proof starts with the given. Do you notice your given starts with a congruent symbol? Anytime it does, mark it in the picture. If you have congruencies, I want the picture marked. BC, that's that one, is congruent to DA. Oops, I forgot my bar. One congruent down. I need a total of 3, so 2 to go. I go through my 5 things that I look for in a proof. I look for words. Are there words?
No.
No. I look for symbols. Are there symbols?
Yes.
Yes, there's both congruent and parallel. Congruent is what we want, so we don't really mess with those anymore. But there's a parallel. Which of our postulate sheet has parallel things on it? Yellow. So, we are told that BC is parallel to AD. In these ones, extending the parallel lines can sometimes make life easier on us. So you'll often see me do that with the parallels. Helps things stand out a little bit better. Because on these proofs, they don't tell you what angles to look for. They don't tell you what the transversal is. There's technically 3 transversals in this problem. One of them's helpful, 2 of them are not. So we're going to break it down. If I look at this transversal, the transversal needs to make one angle in each triangle, that to be a corner of each triangle. When I see the top ones crossing, I see that angle, that's in the triangle. But when I look at the bottom ones, this line and this line crossing, they make that angle, not in the triangle. This angle, not in either triangle. This angle, not in either triangle. And this angle, which is in both triangles. That's not helpful. That's bad transversal. I look at this one, I've got the same issue. Not in a triangle, not in a triangle, not in a triangle, in both. In fact, anytime it looks like this, the useful transversal is going to be the diagonal one. This is our transversal that's going to help us. Because when I cross these lines, this X
will give me this angle in one of the triangles. And this x, this is not fully in the triangle. Be careful of that. That's a common mistake. This is the only one that's fully in a triangle. If I compare this with this, which angle spot is this located in? Three, because it's below the parallel line to the left of the transversal. 3. Which location is this one in? 6. 3 and 6 are what kind of angle pair? AIA. Now, our green sheet tells us that AIA angles, while they might be equal, that means they are also congruent. So in my proof, I want congruent symbols. So, AIA is a theorem, and I want this angle and this angle. What is the name of this angle? Can't call it C because I'm going to ask you, do you mean this one, or this one? CB's a side. CA's a side. Angles require either 1 letter or 3 letters. BCA. Angle BCA is congruent to this one down here. What's its 3-letter name? DCA would be up here. It'd be either DAC or CAD. Remember, the A needs to go in the middle. Guess what? I already marked them as congruent in my picture. I now have 2 congruent symbols in my proof. How many do I need? 3 total. I need to find something else. I go back to my 5 things. Do I have any words? Do I have any symbols I haven't taken care of? Other than the congruence? No. Do I do algebra in these proofs? No. Substitution or transitive property? Not really. Is there a picture? From pictures, generally I'm looking for either vertical angles or I'm looking for them to share a side. Are there vertical angles? Is there anything that looks like this in that picture? Not except for the stuff that I drew in. Do they 2 triangles share a side? Yes. What's the name of the side they share? AC. Shared side. AC is congruent to AC, and which property did I tell you allows you to say that? Reflexive. I have 3 congruents in my proof. I double check my triangles. I look 1 triangle at a time. I see 2 sides. Is that the angle between them? Yes. On this one, I see 2 sides. Is that the angle between them? Yep. That is side angle side. And by side angle side, the triangles are congruent. What can I actually write as my 4th step? The proof tells me what to write for this. Go ahead and flip the page. We're going to skip C, we're going to go down to D. Statements, reasons, start with my given. I see words. Do you see words? I see bisects and I see midpoint. Bisects shows up in two forms. There's angle bisectors and segment bisectors. Is that angles or segments? Segments, because the second one is specifically what gets cut in half. That being a segment is what tells us it's a segment bisector. Segment bisectors allow us to say things are equal or congruent. In these proofs, do we want equal signs or congruent signs? Congruent signs. So, WR bisects SV. This is the segment that gets cut. Segment SV is right here. It gets cut into two segments by this. What are the names of the two segments? SU and UV. SU is congruent to UV. We use the word bisects, so that's definition of, and since it was a segment bisector, segment bisect. Once there's a congruent symbol here, what did I say you should always do? What? Put it on the picture. There was another word. Midpoint. U is the midpoint of WR. Midpoints give us two congruent segments. What are the names of those segments? W, U, and UR. That was the word midpoint, so it's definition of midpoint. Once I have congruent here, I mark it in my picture. I'm out of words. I used them both. I move on. Symbols. Congruent symbols, we want those. There's no other symbols to work with. Do we do algebra in these proofs? No. Substitution transitive property in these proofs? No. Is there a picture I could work with? Do the triangles share a side? When I say share a side, I mean if I outline the pictures of the triangles, I'm drawing the same segment twice. If I outline, nothing's getting drawn twice. Yeah, this is shared, but the individual parts of the triangles are not. What's the other thing I said you can look for in these proofs? Vertical angles. Is there an X? Yes. Gives me this angle and this angle in the triangles. Can I use the letter U as a name, or do I have to use the three-letter name? Three-letter name. What letter better be in the middle? U. So this one is WUV. Don't forget the angle symbol. Is congruent to angle SUR. What were we using for that? Vertical angle theorem. How many congruents do I have in my proof? 3. So, I double check that it fits side, angle, side. One triangle at a time. Is it two sides and the angle between? Side, side, is that the angle between them? Yes. I look at the other one. Side, side, is that the angle between them? Yes. So by side, angle, side, I can say the triangles are congruent. And since that's what I was trying to prove, I can just copy down the proof. These proofs, they're a little bit different to get used to at first, but every single year, 90% of people say, these are the easiest proofs we do. So, even if you're not a fan of proofs, these ones tend to start to make more sense, especially while we are going to continue to do proofs throughout the next week. All of the proofs are going to look very, very, very similar. The only difference between the proofs that we do in this chapter is going to be how we say things are congruent. Because there's side angle side.